Well, hello, everyone. Welcome to our conversation on building scalable, resilient Internet of Things messaging. My name is Gregory Green. I am a solution engineer, part of the VMware Data Services team. And here is a rundown of our conversation for today. We're going to talk about the general problem and how we can address the two main areas, which is scalability and resiliency. We'll talk about the unique challenges of Internet of Things before we wrap it up. Many of the solutions are centered around a RabbitMQ. RabbitMQ is the most popular open source messaging broker. And over the years, I've been building lots of microservice-based applications that utilize RabbitMQ. Now, when we talk about the problem, right? I'm sure many of you have had the challenges, especially you developers out there, you architects out there, when you're trying to you have an application that is taking in information from various sources, and you're trying to size out, okay, how much horsepower do I need in order to deploy my applications? And ultimately, maybe I want to store this in some sort of data store. For example, it might be a relational data store, like the Oracle, SQL servers, IBM's, databases of the world, right? So when you deploy you come up with your plan, your capacity plan, and you push it to production, then all of a sudden you have success. And then you say, oh no, because maybe the amount of traffic that you originally planned, the actual traffic is 5 times or 10 times what you were expecting, right? When you drill down into that, right, let's look at what are the real issues when it comes to scale. Well, one aspect is the applications themselves have lots of responsibilities and what I sometimes call concerns. So think about an application that receives information from a user, from a downstream system. They have to convert the messages to some sort of structured format. Maybe they're responsible for doing validation, transformation, maybe some calculations, computations, before actually storing the results of all the business rules into some database of choice. And then the database may also may be limited in how it can scale. Traditionally, relational database can scale vertically, meaning that it can benefit from having more memory, more CPU power, or more disk space. But it's hard to do that in runtime, in production, especially in a physical environment, right? If you're in a virtual environment, it might be a little bit better, but again, you're still gonna have some level of limitations, and ultimately high throughput can overwhelm traditional solutions like your databases and your applications. And when your solutions are overwhelmed, you have the risk of losing critical information, especially during outages like a database outage. Your applications can try to compensate for a data outage, like doing some sort of retry logic, but it's limited, I should say, especially when you're talking about cloud native applications, because you rely on the database to store the information. Right? You can't really hold it too much information in memory, and you can't rely on disk because in many cloud-based environments like Google Cloud, like Azure, and so on and so forth, like AWS, right? Your disk space is ephemeral, meaning that if you have a restart, you'll lose information that is stored on the disk. So now let's introduce how do we solve that, right? Now, how do we make it from hard to scale to easy to scale? Well, you address the concerns, right, by limiting what certain applications are doing. And one of the fundamental ways you can do that is introduce a message broker. When you introduce a message broker, you can separate sourcing or receiving information concerns from consuming or sync, or basically the final destinations for these messages. So the source applications can be concerned with converting from the raw messages to a structured format, doing some level of validation and some level of business rules, right? But can delegate all the responsibilities for saving these messages into a database to a consumer sync app. And in the middle, you can scale up the number of broker nodes that sort of work together as a cluster, such that if one of the clusters has an issue, they can compensate for each other. And also, you can scale up the number of consumers. This can, at runtime, this can compensate for those increased number of messages that are 5 times or 10 times the expected capacity. And they can do things such that they can throttle or help with back pressure support for the database. And if the database is down, they can keep those messages on the queue, right? So that helps with the reliability aspects of it, in addition to having multiple copies of the messages on the broker to survive outages. Now, Internet of Things also provides some unique challenges. And what do we mean by Internet of Things? It's really related to edge-based computing. That means the information is being produced or being captured where it's produced. So for example, think about vehicles where you want to send statistics information to some central hub. And on the vehicle, you might have software, you might have sensors that collect this information, but in order to send that to a central hub, they may have limited resources in terms of network bandwidth, and also the internet connectivity, especially as you move to areas that don't have, a close cell phone tower, you can lose your network connectivity. So this is a reference architecture of how a message broker like RabbitMQ can address those concerns, right? So imagine on the edge, you have your vehicle app that is producing the information based on the information you're getting from the sensors. And instead of sending that over the wire and implementing at an application point of view, the reliable messaging and the retry logic, you basically just install RabbitMQ on the edge. RabbitMQ has a lightweight footprint, so it can easily be installed inside of devices on the vehicles. And then within the broker, it has built-in capabilities to reliably send that messages from the edge to a central hub. And once it's on the hub, you can do just about anything that you want in terms of introducing any number of consumers that can save not only just in one data store, but different data stores. Like, not limited to just using relational databases. You can use NoSQL databases like Apache Geo, right? That can provide low latency support for visualizing the information into a dashboard. There is a reference implementation of this solution at the link within my GitHub link. So I encourage everyone to please check it out. So I hope that you were able to see how we can to address a scalability of your applications by introducing a message broker, and also improve the reliability by using redundancy and things that are built into the message brokers for reliable messaging, and to improve the throughput of your message processing, such that when unplanned increases in volumes happen in production, again, you're able to handle it in a graceful manner. So thank you so much for your time and attention. It was great, and it's an honor to have this conversation with you at Afrotech.